All right, let's get ready for the test. We'll start with the basic stuff with figuring out how to write an isotope formula for any kind of element. So we'll also see how to figure out how many electrons, protons, and neutrons an element has. We'll start with, let's say we have manganese. Manganese, what you're looking for is two numbers, 25 and this non-rounded number, 54.938. 25 tells us how many protons this element has. Exactly 25. And because atoms are naturally neutral, the number of protons and the number of electrons is a matching number. So if my element has 25 protons, I also know that unless it's an ion, which is an element that has either lost an electron or two or gained an electron or two, we have an uncharged atom. So therefore it's not an ion, and I know that the charge is 0, which means that if I have 25 protons, I have to have 25 electrons to match that. So whatever I have positive needs to be matched by the same number of negatives. So if the number of protons is 25, the number of electrons is also 25. The next number that you see here is the atomic mass number. So how do I figure out the number of neutrons? I'm looking at the atomic mass number and I am rounding it to 55 because 54.9 is 55. So that's my 55 AMU. It's not grams. The unit here is AMU. And then if I look at the mass of my subatomic particles, the mass of a proton is 1 AMU, and neutron is about the same, also 1 AMU, and then electrons are so much less massive. They're about 1,000 times less massive than protons or neutrons, even though they do have the same electrical charge. So mass of electron is basically negligible. That's the smart word that they use for it. So we can disregard it. We can not count it at all. So then, if I look at my atomic mass number, it's 55, which means that if I have 25 protons, then whatever is left over is going to be neutrons. So therefore, 55 minus 25, which is the number of protons, will give me 30. So I know that this element has 25 protons and 30 neutrons. Now, how do I write my isotope number? Isotope formula. So what goes at the top is your atomic mass number, 55, and then at the bottom you have the number of protons. And where you write it, on the left or on the right, it depends on you, basically. If you're right-handed, go ahead, write it on the right. If you're left-handed, go ahead and write it on the left, wherever you want. What would be a mistake, though, is, first of all, if you flip, and then the way Miss Grogan explains it, you write the bigger number at the top, because when you subtract one from the other, that gives you the number of neutrons, right? Because 55 minus 25 is 30, so you write the bigger number at the top and the lower number at the bottom. And then, so this would be wrong. And then also this would also be wrong because you do need to round this. So these two guys would be a mistake. However, this or that, I can circle, there you go. These two will be absolutely right. So you get your atomic mass number at the top, the number of protons at the bottom, and there you go. That's your isotope formula. Now, 25 protons again, 25 electrons, 55 minus 25 is 30, it has 30 neutrons. Now what if you were to write an isotopic formula for an element with 55 electrons? Since it has 55 electrons, you're going into the periodic table and you're looking for something that has a 55 for the element number. So you go 55 is the number of protons and electrons, and then you round your atomic number to 133. And so that's your isotopic formula, 133, 55, and then it has 55 protons, 55 electrons. 133 minus 55 is 78 neutrons. All right, so that's it.